And we're back. Got a new toy, new computer. Can you hear it rustling in the background? It's got a slightly bigger fan. It's one of my biggest fans ever. And I think it goes more quickly as well, so you might see things whiz about the screen a bit more fastly. Well, it makes me feel good. New computers still excite me. Must be my age or something. Anyway, it's still me. It's still Rob Miles. We're still writing games. We've been doing this now for quite a while. I'm sorry if I'm boring you. I'm ever so sorry. This is how I always am. There's people who have to live with me all the time. It's terrible, isn't it? Anyway, moving on. Writing games with C# and XNA. It's all the same. It's all the stuff. We're up to section 2.3. Whoa! Controlling vibration. Yep, you can make it vibrate. That is the gamepad. We did that last time. What I want to do this time is take some control, have different levels of vibration. If you play a proper XNA game, or a proper Xbox game, you'll know the gamepad can vibrate a lot or a little. And this can add a huge amount to the atmosphere of the game. We're going to do that with ours, because what we're going to do is actually make the gamepad vibrate more and more and more. As the game gets closer and closer to the end point. The story so far, quick recap. XNA provides a way of talking to these objects in our game, these gamepads, which is a bunch of types. And one of these types lets us take a look at the values it exposes, so we can take a snapshot of the gamepad, then take a look at the values inside the gamepad and decide what to do. And it all works jolly well, and we've done that. There's two motors in the gamepad, a left-hand one and a right-hand one. One of them is a low frequency, has a big heavy weight on that vibrates slowly and sort of lumpily, and one has a little weight on that vibrates more quickly and gives a more buzzy kind of sound. And that's how it works, and we know about this, and we can control them independently using a method to control that. Which is why it's called the controlling method. Yes, yeah. I'm not getting clever as I get older, am I? I'm just getting more, more me. Anyway, let's move on. I want to do this because it'll make the game a bit more interesting. It also shows us a few things we can do, and we could make a game where you could play the game blindfold. You could see if you could find it. And you can actually have fun with this. You can have 4 gamepads and see how fast someone can find out which one's vibrating the most, and check out how good your friend's tactile senses are, and all that kind of stuff. So there are other kinds of little stupid games you could play with this. We're going to make the XNA gamepad vibrate more as we get closer towards the end of the game. And we know, because I read the XNA book that tells me this, that we can vary the vibration intensity by giving a value between 0 and 1. So the colours go from 0 to 255, with 0 being very dark and 255 being full brightness, but the vibration intensity in the gamepad goes from 0 to 1. So 0.5 is half vibration, 0.9 is quite a lot, and 0.1 is little. This is our first real foray into floating point numbers, or real numbers, ones that have fractional parts. Okay, so we have to do some conversion here. We have a slight issue. We know the intensity value we're starting with goes 0 to 255, and the vibration value goes from 0 to 1. And so we have to do a bit of maths. Computing and maths tend to go together very well, although there's not as much maths in computing as you might think. Most of the time you're trying to think of a recipe. You're trying to think, okay, what can I do to 255, or a value in the range 0 to 255, that would get me a value in the range 0 to 1? Little bit of algebra, not a lot, and you come up with this. You say, okay, take the intensity value, there it is, okay, which goes 0 to 255, divide it by 255, and that'll say how much vibration you want. Now whenever I make an equation like this, I actually test it by plugging some values in and looking at what numbers come out. So if we have intensity set to 0, 0 over 255 is nothing. We get a vibration of 0. I quite like that. Make it 255, and 255 divided by 255 goes precisely once. So that gives me my 1. And if I feed in 128, then the fraction 128 over 255, twiddle it a bit to 100 over 200, and that makes it a half, which is 0.5. So these numbers seem to be alright. Take the intensity value, which is going to be from 0 to 255, divide it by 255, and hey wow diddy-o, we get a value which is in the range we want. So we're doing a bit of this is scaling basically. We're just doing a little bit of math to do some scaling, get the number in the range that we would like. And so away we go with this. Next thing we do, this is how programming works: figure out the solution, figure out what you want to do, then write some code to do it. So we're going to use this actually inside the update method, because that's where our game engine is updated. Remember, XNA has two methods: a draw method which draws the image on the screen, and an update method which actually moves the game engine forward and does all the calculations to do with the environment the game's actually presenting for us. Now, in the case of this particular program, our environment is intensity values and amounts of vibration. It's update that's in charge of all that, and I'm going to make a new kind of variable, one which is local, lives inside the update method and isn't used anywhere else. Very good reason for doing this, because I don't want this vibration value anywhere else in the program. So C# says, okay, make it, put it in a small local area, just use it there and not make it available anywhere else, which makes very good sense to me. So put all this together, end up with 2 lines of C#, make a new local variable which I'm going to call vibration. It's of type float. This is the type that can hold floating point numbers with decimal places. You've got about 7 digits of precision and quite a nice wide range. It's perfectly adequate for what we want. So I'll make a variable which we're going to call vibration, give it the type float, then we're going to do our sum, take the value of the green intensity, divide it by 255, which is the little equation we know will work, put it in vibration, and so now we have a number that tells us how much we want the gamepad to vibrate. The next thing we have to do is set the vibration of the gamepad to that value, and set vibration is actually rather a cute little method. It lives inside the gamepad class, and we give it the number of the gamepad we want to make vibrate, in this case player 1's gamepad, and the amount of vibration for left and the amount of vibration for right. Now I'm going to make them both vibrate the same. If you wanted to get clever with this, if you wanted to sort of do this tactile testing kind of program, then yep, make a program which vibrates them differently. See if you can make the player detect which one's vibrating. There's all kinds of games you can use to play in the dark. And who doesn't want to do that? So there you go. There's our code. All this goes in the update method. We pick it up, we drop it in, and that's just what I've done. So if I then twiddle out of here, drop into Visual Studio, if you drift down the program, this is, you remember, if we press the button A, the amount of green in our program screen goes up, and then here's my 2 lines of magical C#. Take the vibration value, work out the intensity divided by 255, and then use this thing to set the vibration of the gamepad. So all I have to do is press run and be amazed how fast it goes. Watch carefully, folks. Pow! Look at that. Okay, black screen. Fire at me, good old gamepad. You'll have to trust me here. I really am doing this. Press the green key and we get green. We get more green. We get lots of green. We are uber green. We are green in extremis. But, and here's the problem, ain't got no vibration. The gamepad is the silent tomb. Now, at this point you could blame the gamepad. You could blame Microsoft. You could put new batteries in it. You could stand in a bucket of water for 3 hours. Don't advise the final one. None of these things will make the program work because it is broken. If I make it go all the way to bright, full bright, still no vibration. Something is wrong with our code. We have to fix that. I'm going to stop the program now, go away and have a little cry, then come back and we'll see if we can fix this problem. So I'll be back in a minute. Just got to go and do my eyes. Right. Okay, right, back now, and I'm feeling much better, and so I'll drop onto my slides and see if they can help. We've got our little picture of the detective. We're debugging again, but this is completely weird because this time we know it should work. We've done the sums, we've fed in test values, we've done all the bits and pieces we can. We're even carrying our lucky rabbit's foot, although it didn't actually do much for the rabbit. So we'll move on. We know what we want is right, but it isn't working. We have to sort of expand our understanding of what C# does and how programs work to try and get to a happier place. Okay, we have a broken program, we have to mend it. Up until now, and this is how programming really is: analyze the problem, figure out what to do, test it as best you can. In this case we fed some numbers in, they came out okay, and then write the code. Important point to make here: We're not trying to debug a program. We're not throwing bits of code together and seeing if they do something a bit like what we want. We're cleverer than that. We're better than that. We have a solution we know is good, so it must be the way in which we're expressing that which is broken. We have a broken solution which we need to get right. Now, in real life, the main course of errors are a misunderstanding of how the computer's supposed to work, a misunderstanding of what the customer wants, or a mistyping, spelling something incorrectly. We have to figure out what it is that we've done that's stupid, okay? And so we have to do some fixing. Now, it looks to me, I mean, if I was guessing here, I would say the value of vibration isn't being set right, because if vibration is stuck at 0, then that means we're never going to get a gamepad to vibrate in a million years, okay? What I really want to do is take a look at the value in vibration when the program's running. I want to stop the program, take a look inside its brain if you like, see what's going on, and then I can start doing some investigation. I want a magnifying glass for my code if you like. Turns out I can do just this. The people that invented Visual Studio were very keen. They know all about code writing. They're very keen to produce a thing which is going to help you write good code and also find the mistakes that you make. I can put a breakpoint in the program. The breakpoint is this brown dot, and we put it against the line where the program should stop. When the program gets there, it stops running, and we can then take a look at values in the program and see if we can figure out what's going on. So let's do just that. So if I trip back to my program now, okay, the line I want to take a look at is this one here. So what I will do is I'll just click in the left hand margin. You can do this in your version of Visual Studio too. Click there, everything turns brown. Run the program. Okay, now if we look at the program, we have to start pressing the green button, and here we go. If I press green, then bang. Okay, we've actually now got a connected gamepad, and if I look at vibration, it's set to 0. I've hit my breakpoint. The value of green intensity is 1. This is the first time I've hit the breakpoint. And if I step, and there are buttons I can press to step through my program just here, I can move one step at a time. Vibration is still 0. Well, that's okay. What I really want to do is try finding out what happens when vibration's a bit bigger, say like about 20 or so, or 100. So what I'm going to do is another really nice trick. Turn the breakpoint off and set the program running again and get my screen back, and just put some more green in, lots and lots of green. Okay, now the wonderful thing about Visual Studio, and I love this is great, it even works if the program is running in the Xbox. I can now put the breakpoint back when the program is running, and it will stop the program. This is sort of like you can stop the program and look at what it's doing even when it's busy. So if I put the breakpoint in, bang, the program instantly runs so that it sees that again. Vibration has 0 on there. Green intensity's got 101, so yeah, we should see a floating point vibration value of about, well, 101 divided by 255, which should give me just around a half. So I'll step over this line and we'll take a look. Now, vibration is 0. We know that's wrong. Okay, so we have a smoking gun now. We know where the problem is. We know that this calculation, this expression here, is not doing what it says on the tin. Okay, let's drift back to the slides and see what the slides say. Yeah, we've found the bit that's broken. It's as if this divide, which I've told you is a way in which I can divide one number by another, is having no effect at all. It's just returning 0 every time. Now, actually, divide's working perfectly. It's our understanding of the way C# programs work that's faulty. So that's the thing we have to fix. And here's what I mean by that. We're dividing a left-hand operand by a right-hand. Remember, operands are these things that get done in expressions. Okay, operands are like the raw materials, and operators are the kind of things that you do with them. So in cooking, operands are things like I don't know, sugar and flour and water and milk and things, and operators are things like mix sugar and water. Okay, and then you get wet sugar or sugary drink. I don't know, I'm not a cook, but I do know this though. If I use the divide operator and I apply it between a value which gives me the intensity of the green and 255, that should perform a calculation which I can then use as a result that goes into my variable. In other words, this thing makes sense. Operators say what to do, operands are the things what get the thing done on. Okay, that's the way it works. Right, but it's not doing. So we have to figure out why. Operands, yeah, there you go. We have two of them, green intensity and 255, and our operator is divide, and we've got a picture of a confused dog, which makes things much easier to understand. That works for me every time. Fantastic. This is the thing we didn't know. Okay, if you get this, then you're on the way, you won, that's it, we're sorted. The divide operator, well, it depends on where it's... I mean, let's put it this way. If you're taking tea with the Baroness, okay, you'll behave differently. Okay, you will not use the same words. You will crook your little finger when you drink tea. You'll say, "Oh gosh, blimey," when you trap your finger in the door, rather than other things. The way people behave depends entirely on their context, where they are, and who they're with. Okay, the divide operator is just the same. It behaves differently depending on where it is and who it's with. If it's surrounded by integers, it'll say, okay, the customer wants an integer result. In other words, no fractional bits. I'm not going to do any rounding. I'm just going to go, okay, divide this thing by this thing, throw away the remainder, and that'll be me sorted. So in this particular case, if you look at the maths, okay, let's do some little sums now. Integer division. 20 divided by 7, well, 27 goes into 22 times with 6 remaining, because 7 plus 7 is 14. Take that away from 20 and you get 6. So the answer to this one here, 20 divided by 7, is 2. Okay? 14 divided by 7, that's 2 as well. So we've lost a lot of stuff today. 100 divided by 10, well, 10 goes into 100 10 times. 255 divided by 255, that's 1. 254 divided by 255 is 0. Remainder 254. In other words, no matter how big that one gets, because we're throwing away the fractional bit, we're not doing a proper division, we're not getting a floating point result, we're always going to get 0. So the fact we're using integer division in our program has broken it. Okay, we didn't know that when we started, but now we do. So we're making progress. All good stuff. Okay, fix it. Well, I can't. I have to get the right context for the divide operator. I have to persuade it to do its floating point trick rather than its integer trick. It's a bit like taking your friend to tea with the Duchess, because that way you might find that they'll behave better. Although that could actually be a fairly dangerous approach. The idea here is that I want to put things around the divide operator to make it think, we're doing floating point here, which means I must do a floating point division. And the way we do that is to make one of the operands in our calculation floating point. And C# has a technique built into it specifically for this job. To say to the compiler, I know that green intensity is an integer, but for the purposes of this calculation, for the thing I want you to do next, I want you to treat it like a float, please. So putting a type, in this case float, in brackets in front of a variable tells the C# compiler, okay, I don't know, well, I know what this is, but I don't want you to regard it as that. I want you to regard it as this. It's called casting or casting, depending on how posh you are, whether you're with the Duchess or not. Okay, and it's a way of casting from one type to another. You come across this in movies. Casting kind of makes sense in that context. Starring Christian Bale as Batman. The person that plays Batman is not actually Batman. Okay. Bear this in mind next time you see the film. It's not him, it's someone pretending to be him, okay? But during the film we think, Christian Bale, Batman, yeah, that's fair enough. In programming, casting is just the same. We go, right, it's not an integer, it's a floating point for this bit, okay? And because they're both numeric types, because they both hold numbers, it works fine. We can't do stupid casting. You can't cast one type of number into a brick wall or a string or a piece of wood or something. You can't do that in movies. You can't say, starring Christian Bale as City Hall. Well, actually, you could do that. I'm thinking about a joke involving actors and chairs and wooden and things, but we'll move on from that. You wouldn't do that. The compiler will let you do sensible things. It'll take a look at what you're doing and say, yeah, number to number, that's okay. I can live with that. So as far as I'm concerned, I have to make a tiny change to my program and I get my good vibrations. So go back to the code. I have to stop it. So press the stop button, just like a video recorder. Stop, pause, play. Press the stop button, my program stops, and now I can take out my breakpoint. I can drift into here, and remember I want the compiler, that's a bit shouty, to regard the green intensity value as a floating point. So I'm saying cast you to a float, which means this divide will now do floating point divisions. Hurrah, hurrah. Press the button to start it running. Get my gamepad to the microphone, start increasing green, and that way you can hear that. I can. It's revving up now. Getting more and more vibrating, and then finally it stops at 0 again. So if put it on the piece of wood, do it again. Okay, this is getting slower and more, and then it stops. So it's working fine. We're getting numbers. If you want proof, okay, I'll take it halfway to halfway brightness about there. I'll bring in Mr. Breakpoint. Where's my mouse cursor? There you are, my friend. I'll go into the program. I'll stop the program. About there we should do it. Press the button again. Come on. Ooh. Ooh. It's stopped there. It's gone yellow. You fool. Vibration is about to be set. Perform this statement. The green intensity is 85. 85 over 255. Let's see what the computer thinks it is. Bang. It comes out as 0.33333. Lovely. About a third. Fantastic. Other nice things then we've seen. I can hold the cursor over a value and it'll show me what it is, which is really nice. And I can run the program on again. Press run, take the breakpoint away, run it again, get my screen back. So now, oh, come back, there you go. I can just, and it works. So we now have it gets more and more exciting type behavior to our game, which is really rather sweet. So I shall drop back here. And then I'll drop back here, even better. And we now have good vibrations. C# doesn't do this to make our lives more difficult, okay? It's nice, really. It looks like it's being nasty, but what it's really doing is saying, look, if you're doing sums involving numbers with no fractional bit, I'm not going to waste my time actually working out that answer. I'm just going to go, okay, fine, I'll give you a non-fractional bit on the end. C# tries to use the most appropriate operator, and it figures this out in terms of the context in which it's being used. So it won't waste time making floating point calculations if it doesn't think you really care about the actual fractional bit. In this case we did care, but we were starting with integers, so we had to actually tell the compiler, okay, I know it's an integer, but for the purposes of this sum, please make it floating point and I'll love you forever, or something. Okay, so we know that C# provides a float type which holds numbers that have fractional part, and we know that when you do an expression you have these operands, these numbers that get fed in, and these operators that do the work on them, and we know that where the operator is in terms of what's sitting around it determines how it behaves. Normally speaking, not a problem. If we want to change the rules, we have to use this thing called casting to force an operand to be a particular type. And that's what we've learned. Isn't this wonderful? Okay, true or false? Ha! Floating point numbers are always held exactly. Well, it turns out, remember our 0.333333, a third is really hard for a computer to hold. Okay, it can't hold it exactly, and so that one is red. The good news is that floating point is accurate enough for our purposes. So as far as we're concerned, the fact that it's holding a third as 0.33333 is not a big problem. It can hold some numbers very well, because if I have a half is easy. Half is 0.5, that's easy. But 0.3333 tricky. Okay, so that one's false. Sorry about that. Integers divided by integers produce integer results. Well, that was the cause of our problem. That's green. An expression contains operators and operands. Well, since I spent some time a few minutes ago telling you that's what it is, the answer to this one is going to be green, and it is. Operands work on operators. Ooh. About time I had a red one, isn't it, really? No, operands do not work on operators. It's the other way round. Operands are your milk and your bread, and not bread, you don't put, well, you can cook with bread. Anyway, operands are the food stuff. Operators are things like mixing and folding and cooking. They're the doing things. So that's the way it works, and that's why that is red. Casting only works with integers. I haven't really gone into this, but as far as we're concerned, if I'm moving between number types, I can cast where I want to do. I can cast back from from float to integer, integer to float, int to byte, as long as I know what I'm doing. But do remember that, as Spider-Man's uncle said, this is a superhero episode, this one, with great power comes great responsibility. If you cast something, you're basically saying to the compiler, I'm removing one of your safety checks. I'm forcing my understanding of the problem on what you think may or may not be a wise thing to do. So I can force a number to be a particular type because I know that at that point in the program it makes sense to do that. If I'm doing something stupid, then the program will tip over and serve me right. So that's not true, but the power it gives you, the fact that you can cast what you like to what you like in number terms, does mean you could write programs that don't quite work right, but the compiler wouldn't give you any warnings because you've told it, you've overridden it basically to say, do it my way, and then take the consequences. So remember that one, worth bearing in mind for later. Right, bit of fun now. There's some code you can write. If you've got two gamepads, okay, you can use code like mine to send secret messages, because I could press a button on gamepad 1 and make gamepad 2 vibrate, and vice versa. Gamepad 2 could make gamepad 1 vibrate. Best with wireless gamepads. It's a bit of a giveaway if there's a big cable trailing to your jacket pocket. If you can mysteriously read your friend's mind and there's this dirty great big wire going across the room, bit of a giveaway. But with wireless ones it can be fun, and you can do things like put the gamepad on a tin tray under someone's bed and then wait till they were asleep and let fly. That's quite amusing as well. But don't tell me it was my idea. But we want to have a communication thing. We're going to write the code to do this. We had a programmer hired, but apparently he's telling us that he's been eaten by a congreal and can therefore no longer write the code. So we have been given a bunch of starting points and a bunch of things to do, and then we have to go and do them. So that's our job, and we'll have to do that because that's why we're here. This is the end of section 2, basically. We have to do the lab now. It'll all be on verysillygames.com/screencast along with everything else, the source files, the whole lot, the full Monty, the whole enchilada, the big cheese, and any other sort of lots of it things you can come up with. As for me, well, I'm going to go and put those files up on the website so you can find them. There'll be more stuff next time. I hope that hope that was fun. I'm going to have a lie down now, actually, then I'm going to do the stuff, so there you are. But anyway, until next time, it's bye bye from me.